Welcome back to Edutube. Have you ever been stuck in a traffic jam, waiting endlessly as cars crawl along a narrow road, while you wonder why the highway can't handle all those vehicles at once? Well, that's a lot like what happens with many blockchain networks today. In this lecture, titled Blockchain Scalability Issues and Solutions, we'll explore the challenges that blockchains face when trying to process lots of transactions quickly and the innovative solutions that are being developed to overcome these hurdles. Scalability is crucial if blockchain is to be used by millions of people in everyday life. Today, we'll break down what scalability means in the blockchain world, discuss the problems that arise when a network becomes congested, and look at the practical solutions that developers are working on. By the end of this video, you'll have a clear understanding of both the issues and the fixes, and you'll see how these concepts relate to something as familiar as improving traffic flow in a busy city. What is blockchain scalability? Let's start by defining scalability. In simple terms, scalability refers to a system's ability to handle increased workload. In our case, how many transactions a blockchain can process per second without slowing down or becoming too expensive to use. Imagine a small country road. When only a few cars are on it, everything runs smoothly. But if suddenly hundreds of cars try to use that same road at the same time, you end up with a jam. Similarly, a blockchain network may work perfectly under light use, but as more users try to transact, the network becomes congested, leading to delays and higher fees. Key factors affecting blockchain scalability include transaction throughput, how many transactions per second, TPS, the network can process. Network congestion, when too many transactions compete for limited space in each block. Latency, the time it takes for a transaction to be confirmed. Cost, higher fees often result from congestion as users bid to have their transactions included. For instance, you may have experienced slow transaction times and high fees on certain cryptocurrency networks during periods of high activity. This is a direct result of scalability issues. Common scalability issues. Now let's delve into some common challenges. Many popular blockchains, like Bitcoin, can only handle a handful of transactions per second. This is far less than what's needed for global, everyday use. Think of it as a single-lane road that becomes a bottleneck when traffic increases. When the network is congested, users end up paying higher fees to get their transactions processed faster. Imagine paying extra tolls during rush hour just to bypass a traffic jam. Slow confirmation times can be frustrating. When too many transactions are queued, it can take minutes, even hours, for a transaction to be confirmed, much like waiting at a red light that never seems to change. Some blockchains require significant computational power to maintain security through consensus mechanisms. This means the network can become slower and more expensive as it scales, similar to how a computer can slow down when too many programs run at once. Daily life analogies for scalability issues. Let's relate these technical issues to everyday life. Imagine you're heading out for a family road trip on a busy weekend. If you take a narrow road that suddenly becomes jammed with cars, your journey slows dramatically. You might be forced to pay extra for an express toll road to avoid the congestion, or you might just be stuck waiting. That's exactly what happens with blockchains during peak times. When too many people try to use the network at once, transactions slow down, and the cost to get through increases. Another analogy. Think of ordering food from a restaurant during a busy dinner rush. The kitchen has limited capacity, so your order might take longer, and you might even pay extra for priority service. Similarly, blockchain networks have limited capacity, and when demand is high, users bid higher fees to get their transactions processed faster. Solutions to blockchain scalability issues. Now that we've covered the problems, let's look at the promising solutions being developed to address blockchain scalability. These are protocols built on top of the main blockchain, Layer 1, to offload transactions and increase throughput. For example, the Lightning Network for Bitcoin allows for off-chain transactions, which settle on the main blockchain later, reducing congestion and fees. Imagine creating a separate express lane on the highway where cars can travel faster, then merging back onto the main road once the congestion eases. Sharding involves breaking the blockchain network into smaller, more manageable pieces called shards. Each shard processes a portion of the network's transactions in parallel. Think of it like dividing a long queue into several smaller lines, so people are served faster overall. Ethereum 2.0 plans to implement sharding to dramatically increase its TPS, making it more scalable for global use. A sidechain is a separate blockchain that runs parallel to the main blockchain. Transactions can move between the main chain and the side chain, effectively distributing the load. Picture a suburb connected by multiple side roads to a busy highway. These side roads help divert traffic and reduce congestion on the main route. Many blockchains are exploring or have already implemented more efficient consensus mechanisms. For example, proof of stake, POS, is less resource-intensive compared to proof of work, POW, and can process transactions faster. It's like upgrading from a hand-powered machine to an electric one, more efficient and less costly. Developers are continually working on optimizing the code and protocols of blockchains to improve their efficiency. This is similar to how traffic engineers improve road layouts and traffic signal timings to make urban traffic flow smoother. Real-life examples and analogies for solutions. Let's bring these solutions to life with some everyday examples. Imagine a busy airport where all passengers go through one security line, causing long delays. Now think of a separate fast-track security lane for frequent flyers. Layer 2 solutions work similarly by providing an express lane for transactions, reducing congestion on the main blockchain. Picture a popular pizza delivery service during a festival. Instead of one giant kitchen handling all orders, they set up several smaller kitchens in different parts of the city. Each kitchen handles orders in its region, and the overall delivery process becomes much faster. That's sharding in blockchain, dividing the network to process transactions in parallel. Think of a large shopping mall with multiple entrances and parking lots. Instead of everyone trying to get in through one door, side entrances help distribute the crowd, making the process smoother. Sidechains serve the same purpose for blockchains by offloading some transactions from the main chain. Consider two different types of voting systems in a community. The first requires every member to cast a paper vote, like POW, which is slow and resource-intensive. The second uses a quick electronic voting system like POS, which is faster and more efficient. Upgrading to a better consensus mechanism can speed up the entire blockchain network. Let's recap what we've learned today. Blockchain scalability is about how well a blockchain can handle increasing numbers of transactions. Current issues include limited throughput, high fees, congestion, and latency, much like a narrow, busy road during rush hour. Solutions such as Layer 2 protocols, sharding, sidechains, and alternative consensus mechanisms are being developed to address these challenges. Real-life analogies, like express lanes, multiple kitchens, and fast-track security, help illustrate how these solutions work and why they matter. Scalability is essential for blockchain to become a practical tool in everyday life, and the innovations in this space are driving us toward a faster, more efficient, and more accessible decentralized future. Now, I'd love to hear your thoughts. Have you experienced blockchain congestion or high fees? What do you think of the proposed scalability solutions? Leave your comments below and join the conversation. Thank you for watching, and I'll see you in the next video as we continue our journey into the fascinating world of blockchain technology.